when we have to apply this Hund's rule of maximum multiplicity. For that purpose, keep in mind PDF. Either of that orbital should be last orbital, and second implied condition, that should not be fully filled. For s orbital, such splitting is not there. For p orbital, just as shown, px, py, pz. If orbital is d, then d orbital is split up into dx square minus y square, dz square, dxy, dyz, dxz. So like that, 5 splits are there, because you are aware d orbital is having 10 electrons. Each orbital should have only 2 electrons. So in order to that, d orbital is split up. Keep in mind, d orbital is also degenerated orbital. But in excited state, it splits up. 2 will go upside, 3 will go downside, but that is not right now part of our study. So this part, time to time, whenever particularly we discuss d block element, at that time we are going to discuss in detail. So here, this way we can check out the split of d orbital. Quantum numbers. Keep in mind, whatever we have discussed right now, that only I am going to discuss once again, and little bit here and there. Only we are giving names now. So first we are saying quantum numbers. So there are total 4 quantum numbers we have to study. The first quantum number we have to study, that is called as principal quantum number. We have discussed this as we discussed that there are shells that we are calling them as n equal to 1, 2, 3 and so on. They are also termed something like n equal to 1, that is k, then l, m and so on. So this is called as principal quantum number, denoted by letter k, l, m, n, like that. Generally we denote it as small n, that is mention number. It is all integers starting from 1, 2, 3, 4, like that. Theoretically speaking, infinite shells are there, but practically we are aware that we discuss only 7th is the last shell for existing number of electrons. So keep in mind, last known element, naturally occurring last known element is uranium, atomic number 92. Then onwards, all elements are synthetic element. So you might have noticed that a new element is discovered having atomic number 100, then 105, 107, 111, like that. So all these elements are synthetic element. They are having higher atomic numbers, but not necessarily electron number is same, and therefore we are not discussing much of that. So we are discussing, in our knowledge we discuss uranium 92, where 5F was the last shell. Even it is not having 7F, 6F is also not there in case of uranium, and therefore we are not discussing much of that. Now we are aware of principal quantum number. We say theoretically speaking infinite values are there, but practically speaking 7th is the last shell. Now this is called as principal quantum number. Second quantum number we are going to discuss, that is denoted by letter small l. This is called as azimuthal quantum number. What word we are using here? Azimuthal quantum number. So azimuthal quantum number is having value 0, 2 and -1. I am writing this way. Many times it is mentioned that only n-1. No, it is having value from 0 to n-1. Let me clarify. If shell number 5 is there, let us consider shell number 5. For shell number 5, obviously n will be equal to 5. if n is equal to 5, then value of L will be 0, 2. Now 5 minus 1, that will be 4. And therefore values are 0, 1, 2, 3, 4. Getting idea? So this way value of L, that is determined. It is not only 4. It is 0 to 4, all integers we have to consider. Now let us go step by step, straight away. Just I have shown what is L, but now we are going to discuss somewhat detail. So let us consider n equal to 1. If n is equal to 1, then L will have value from 0 to n minus 1, that is from 0 to 1 minus 1, that means from 0 to 0, that means only 0. Now, if I am writing electronic configuration in the manner that first shell, that is principal quantum number, followed by azimuthal quantum number, we may read this as 1, 0, no, rather many people may read this as 10, and confusion is there. To avoid that confusion, this 0 is written as S, and therefore value of S is actually speaking here 0. Don't misconcept between capacity and value. Capacity is number of electron we can accommodate, that is 2, whereas 0 is value of azimuthal quantum number. Now, as a result, you can check that 1s, because n equal to 1, there is only s. We have not written here 1p, 1d, 1f. So first shell is only having value s. Now let us put n equal to 2. You will find the value of L will be 0 and 1. 2 minus 1, 1. So as value is 1, it is denoted by letter P. That's why you will get here 2s and 2p. There is no 2d, 2f. Only 2s and 2p. Let us consider n equal to 3. The value will be 0, 1, 2. Why 2? N minus 1. So 3 minus 1, 2. So 2, that means D, and 3, that is F. Rest of the things may be there, but we don't want to write because electrons are not there. So n equal to 3. N equal to 4, then L value will be 0, 1, 2, 3. Getting idea? So n equal to 2, only 2 orbitals are there. N equal to 3, we are getting 3 orbitals now D. But F is absent. N equal to 4, you will get all 4 orbitals, 1, 2, 3, 4. So for 4, S, P, D and F, all these orbitals are available. So this is called as azimuthal quantum number. That's why I told that whatever we have discussed, that only we have to discuss again. But repeating, but we are adding out one concept more. So here we discuss principal quantum number, azimuthal quantum number. But while above principle discussing, we didn't discuss that. But now you are aware that how values are assigned. When we are talking 3p, say while writing I will write 3p. But in your mind it should be clear 3, but p means what? 1. So we have to keep in mind it is 3 and 1. But if I am writing 3 and 1, then one may read 31. And therefore this arrangement is there that second number is replaced by letter. But that second number or that letter, that is called as azimuthal quantum number. Now we have to discuss third quantum number, that is called as magnetic quantum number. Now we are going little bit detail. According to according to Sir J.J. Thomson's atomic model, electrons were stationary. They were embedded in the atom. That is also watermelon shape, something watermelon model. But when we are talking of Rutherford's model, electron is not stationary. electron is in motion, it is performing circular orbit around it. According to Niels Bohr's model, nucleus is at center, suppose. Electrons, they are forming a cloud over nucleus. It is, for example, distributing equally around nucleus. Now here, if you check out the radius, or rather I should say diameter of atom, it is of the range in terms of angstrom. You are aware that 1 angstrom, that means 10 raised to minus 10 meter. That means simply I have to say 1 upon 10 to the power of 10 meter. Now see the calculation. Whereas what is speed of electron? Almost equal to speed of light. Not exactly equal to speed of light, but it is almost equal to speed of light, and you are aware speed of light is 3 lakh km per second. So in a second, electron should travel not 3 lakh, let us imagine 2 lakh kilometer. Not that slow, but yes, let us imagine. So 2 lakh kilometer distance electron will cover within 1 second. But the available space is 10 to the minus 10, 10 to the power of minus 10 meter, less than that. So 1 upon 10 to the power of minus 10 meter. So tiny space is available. So imagine the way electron will revolve around nucleus, and then can we locate out an electron? Answer is no. It is very, very difficult for us to locate out an electron. Keep in mind, nobody ever seen all this. I am not able to see single atom. In childhood, I was having concept something like that. With microscope, we can check out cell. We can observe cell. In the cell also nucleus is there, vacuoles, and all these things are there. So like that, there will be some microscope. With that help of microscope, we can see the atoms. But yet no such atom, no such microscope is developed yet. That's why we have to go on imaginary basis. Suppose you have this type of microscope. I am saying again, it is not developed yet. Student may have misconceived that electron microscope can able to locate out electron. Answer is no. But suppose imagine you have such a microscope where you can see single atom, like huge football. Like that, if you are able to observe single atom, then can we locate electron there? Answer is no, because electron will complete 2 lakh kilometer distance in 1 second. It's greater than diameter of Earth. It is greater than circumference of Earth. Too high, too long distance that will cover within a second. And so there is a principle that is called as Heisenberg's uncertainty principle. I am revising name of principle, that is called as Heisenberg's uncertainty principle. According to this principle, it is difficult to locate out an electron. Either we can locate out exact position of electron, or we can locate out, we can find out exact momentum of electron. But right now, forget of momentum. So with Heisenberg's uncertainty principle, I can say certainly that it is difficult to locate out an electron in atom. Then what I can locate out? I can locate out the area. I can locate out the region where electron finding probability is maximum. I'm not saying where electron will be there. I can get that electron. What word we are using here? Electron finding probability is maximum. That region is called as orbital. Getting idea? Now these orbitals are having different shapes. For example, s orbital, keep in mind, s sphere. So s orbital is spherical in shape. Electron density is distributed all around nucleus equally. So this is something shape of s orbital. The p orbital is having dumbbell shape. Now in our book it is written as dumbbell shape. I am saying dumbbell shape. But I should say rather, instead of dumbbell, that shape resembles to infinite sign to closer extension. This is the shape. So what I should say? Infinite. but in book it is written dumbbell shape, so I am saying it is dumbbell shape. So this is, or if it is vertically this way, then we can say shape of 8. That is also right option. But they say it is shape of dumbbell. So we are saying dumbbell shape. Now second part. When we observe spectra, you are checking out, we discuss about spectra. Spectra means what? That particular radiation is emitted by substance or particular radiation is absorbed by substance. If substance is absorbing radiation, then we are calling it as absorption spectra. If substance is emitting out then we are calling it as emission spectra. So right now we are concerned about emission spectra. So particular wavelength only emitted. But if you place that sample in strong magnetic field, then spectral lines are split up into two parts. If you are placing that substance in strong magnetic field, then you may observe spectral lines are split up. This effect is called as Zeeman effect. Now instead of magnetic field, suppose we use strong electric field, direct current. So if you are using strong electric field, then same effect is observed. This is called as Stark effect. Why this is so? To account this, they carried out research and they say that p orbital is having dumbbell shape. Electron density, now you are aware of this word electron density, that means where electron find, it is not density of electron. Electron finding probability is maximum in particular area, then we say electron density is more. So let's say this is the coordinate system. This is called as x-axis, this is called as y-axis, this is called as z-axis. Actually, on this board, this is x and this is y, whereas z-axis is protruding out like this, perpendicular. But I can't show 3D, and therefore I am showing only 2D. That's why I am tilting out. Say, don't say this is an acute angle. This is also a 90 degree, that is perpendicular. This is also 90 degree. Okay, just imagine this is three-dimensional. So, if electron density is distributed along with x-axis, in case of p, then this is called as px orbital. If electron density is distributed equally in case of y orbital, y-axis, then it is called as py. And if electron density is distributed equally in this direction, dumbbell shape, towards z-axis, then it is called as pz orbital. So this is px, py, pz. This is in order to account Zeeman effect, Stark effect, all that. So this way shape of orbitals are there. Now we have to account this, that is called as magnetic quantum number. So we are now focusing over magnetic quantum number. Magnetic quantum number is denoted by letter m, and values are something like that for every value of azimuthal quantum number. Because we are aware azimuthal quantum number is connected with principal quantum number. So every value of azimuthal quantum number, it is having minus L to 0 and 0 to plus L. Let me clarify. If n equal to 1, we are aware if n equal to 1, then L equal to 0. And therefore magnetic quantum number will be minus 0 to 0 to plus 0. But keep in mind, yet no mathematicians with my knowledge, but no mathematicians are able to detect this type of figure minus 0 and plus 0. In maths, there is only 0. 0 can't be minus and can't be plus. So magnetic quantum number value is 0. That's why electron density is distributed everywhere equally. That is s orbital. But when we are talking of p orbital, let us check L equal to 2, N equal to 2. If N equal to 2, then value of L is 0 and 1. So if L is 1, that means orbital is P. For P orbital, I may say minus 1 to 0 and 0 to plus 1. That means P orbital is splitting out into 3. One is Px, other is Py, and third is Pz. Try to recollect, we discussed this everything under name Hund's rule of maximum multiplicity. So this is called as Hund's rule of maximum multiplicity. For that purpose, we discussed the split of P orbital into Px, Py, Pz. But energetically, their energy is same, whether electron density is arranged according to x-axis, y-axis, or z-axis. And therefore, these orbitals are called as degenerated orbitals. That means they are having same energy. Now, this is magnetic quantum number. If D is there, then you are aware D value is 2. So we have to give value as minus 2, minus 1, 0, plus 1, plus 2. So D orbital is divided into 5. 2, 3, 4 and 5. Just we discussed in earlier part, that is dx square minus y square, dz square, dxy, dyz, dxz. So like that. So this is called as magnetic quantum number. After that, last part we are going to discuss, that is called as spin quantum number. This also we discussed. Electron is having spin motion. One is clockwise, other is anti-clockwise. So if electron spins clockwise, we have to denote it by plus half. Whereas electron is spinning anti-clockwise, it is denoted as minus half. So this way, spin quantum number is there for every orbital, plus half and minus half. Now why spin quantum number? We are denoting here in terms of plus half and minus half. I am not going in detail, but only want to explain. There are categories of particles. No doubt, electron, proton, neutron, all these things. But there are many particles, and then they are categorized as fermion and boson. If fermion is there, the particles are denoted by value half, 3 by 2, like that values are there for fermion. So electron belonging to this category fermion, therefore electron is denoted as plus half and minus half. So plus half means clockwise spin, minus half means anti-clockwise spin. So like that, spin number that is there. So total 4 quantum numbers are there. As I discussed, first quantum number is principal, second is azimuthal, third is magnetic, and fourth spin. I hope you are very much clear about these all quantum numbers, but yet I want to give you example. So take it. Simple exercise you have to perform. Give all 4 quantum numbers of last electron of chlorine. I am revising. Give all 4 quantum numbers of last electron of chlorine. Now you are aware that chlorine, first we have to go by electronic configuration of chlorine. So chlorine is having atomic number 17, so I have to assign 17 electron. So just take down, you have already carried out electronic configuration of chlorine, you can check it down. 1s2, 2s2, 2p6, as it is 3p5, I have to assign that 3px, 3py, 3pz. So first electron, that's why we are showing here half. Otherwise I have to show by full arrow. But this is to indicate half means what? It is category of fermion. 3py, 3pz. Z. 3. I have to accommodate 5 electrons. So this is 4th electron. This is 5th electron. One clockwise, one anti-clockwise. So what is remaining electron? That is 3pz is the last. So I have to assign quantum number of 3pz. So first I have determined which is the last electron that is there in 3pz. And now we are writing out, see, 3p. So first I have to write down principal quantum number. So as I am talking of only this electron, principal quantum number is 3. Azimuthal quantum number, it may be 0, 1, 2. But I am talking of only this. As a result, azimuthal quantum number of P. P means what? 1. So here L equal to 1. Now magnetic quantum number, you are aware, -1, 0, +1. So with this terminology, it can be +1. And lastly, spin quantum number, that I don't know because electron is unpaired. So it can be clockwise or anti-clockwise. So like that, we can find out from this data all 4 quantum numbers of last electron of chlorine. Same way, we can go here and find out, now you carry out exercise in the same fashion. Last electron of phosphorus, atomic number 15. So electronic configuration is there in front of you. You can check out with that. You'll get the data this way. So 3px, 3py, 3pz. But again same thing. I have to focus on 3pz. So as it is 3pz, same data is repeated. N equal to 3, L equal to 1. But M equal to +1 and S, that will be either +half or -half. So that is there for phosphorus. One more exercise. Find out all 4 quantum numbers of last electron of potassium, atomic number 19. First you do, pause this video, then observe. Potassium atomic number 19, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So last electron is there in 4s1. Now I have to go by 4s1 configuration. So as I am writing here 4s1, it's very clear that n equal to 4, L, no doubt 0, 1, 2, 3, but yet it is S, and you are aware S means what? 0. So L is 0. So there is no +0 and -0. So magnetic quantum number is also 0. Whereas spin quantum number either +half or -half. So this way we can find out quantum numbers, all 4 quantum numbers of atom, of all electrons. Now one more named data, that is called as Pauli's exclusive principle. He is the intelligent one. By observing all these things, he says in a single atom, no 2 electrons are having all set of quantum numbers same to same. I am revising. In a single atom, we can't find 2 electrons having same set of all quantum numbers. Is it true? Answer is extremely. So you can take any orbital. Say for example, let us check example. I will give you example. Let us go for magnesium. Magnesium is atomic number 12. So atomic number 12 means electronic configuration 1s2, 2s2, 2p6, 3s2. Let us consider 3s2 set. So electron 1 and electron 2. N, obviously you can check 3s, therefore N is 3. Here also N is 3. L, Si, so 0, 0. M, as L is 0, M is also 0. So here all three sets are same. But fourth set, spin quantum number, if this is plus half, then this is minus half. And if this is minus half, then this is plus half. Because in orbit, we have to show electron like this. One is clockwise, one is anti-clockwise. As a result, all four sets are not getting same. Lastly, spin quantum number differs. This is Pauli's exclusive principle. Alright, so we discuss, name-wise we discuss, say for example, Aufbau principle. Aufbau means to fill up. Then we discuss Hund's rule of maximum multiplicity. Then we discuss Heisenberg's uncertainty principle. Then we discuss Zeeman effect, Sturck effect. Then all quantum numbers we discuss. Now we discuss about Pauli's exclusive principle. This way we discuss almost all part of atomic structure. I am again saying that it is not 100% knowledge. Okay, but comparatively good set of knowledge is provided to you. Time to time when we proceed further, this lecture you have to consider as fundamental lecture. As we proceed further, time to time, we are getting different data. Okay, so electronic configuration right now I have explained that is according to Aufbau principle. But when we will discuss electronic configuration about lanthanide element, then only Aufbau principle is not working there. We have to use some different principles also. So with fundamental knowledge, this chapter is almost all finished. Yet few things are there. After all this discussion, in latter phase, scientists discovered, for example, de Broglie. De Broglie says electron is not a particle. Electron is wave also. Then we have concept of dual nature of matter. At a time, matter can be experienced in form of wave, and at a time it can be experienced in form of matter. So like that dual nature of matter, if you are applying that, then how we can say that electron is having positive charge or negative charge or something like that. Just we discussed there is antiparticle of electron that is called as positron having positively charged. So like that various concepts are there, and that's why changes occurred. Then there is equation that is Schrodinger's equation, but I am not discussing that. I have ended the chapter till Heisenberg's uncertainty principle, that it is difficult to locate out an electron in atom. So we can find out a region where electron finding probability is more. So this is all about our discussion. Thanks for observing this.